What's up guys, and welcome to this first video ever that I'm making, and also the first video in a series on programming in Haskell. In this first video I will go over some brief motivation as to why you might want to learn Haskell, and also what Stack is, which is a program that we'll be using throughout the series in order for everyone, whether you're on Windows, Mac or Linux, to follow along. So let's jump into it. So, first of all, Haskell is named after a logician called Haskell Curry. Haskell, as a programming language, is heavily inspired by mathematics, especially logic and lambda calculus. So this is where the name comes from. Haskell is a pure functional language, as opposed to other languages that are often addressed as functional, such as OCaml, F#, Scala, Erlang, and so on. These programs you have the opportunity to follow the functional paradigm. However, you're not restricted to it, and you can write object-oriented code if you want to, and so on and so forth. Now, the functional programming paradigm has some key concepts that differ from paradigms like object-oriented programming. One of them is that a program consists of functions. There are no classes that you might know from other languages like Java, for instance. And these functions have no side effects. This is one of the important things about functional languages. No side effects means that functions won't access the memory state of your program, and it will only change whatever is in the local scope of the function. This goes hand in hand with the fact that data in Haskell is immutable. This is different in some languages. For instance, when you call a function, the function can alter values of variables inside your program. This is called mutability. It can return something, or it can do both of those things, right? It can alter something, some variables, and return something. Functions in Haskell can only return something, and functions should always return something. And they will always return the same thing, meaning that if you give it some argument, it will always give you a specific output. And this means that Haskell is a great language to do parallel programming in, right? Because as if we are running a program concurrently, we won't have to worry about one function changing the value of some variable that another running function doesn't expect. Because of this, Haskell has recently gained more popularity, I think, and I think that's great. Also, Haskell, there has no sort of control flow or flow control or conditional statements such as if or else statements or for loops, right? Instead, it uses recursion and pattern matching and conditional expressions, which all the things that we'll get more in depth into as we start programming in Haskell. Also, Haskell has something called type inference. Type inference is sort of the best of both worlds from statically typed languages or dynamic languages. For instance, if you've ever written something in C, you always declare your types of the variables. In something like Python, which is a dynamic language, that doesn't matter. You can essentially assign any type to any value, or it's sort of any variable. So type inference is sort of if you write 2 plus 2, for instance, you won't necessarily have to give it a type declaration, although you can if you want to. Haskell will try to infer that because there's a plus in there, it could be something that is part of the numeric generic type from Haskell, such as an int or a float. Okay. Lastly, there is something called lazy evaluation. Lazy evaluation basically just means that it won't evaluate something until it should be used. Okay. So, for instance, I gave a small example here. Let's say that we have a function. This is a very stupid example, but I think that it illustrates the point very clearly. So we have a function here called add2. Takes two parameters, x and y, but it doesn't use them. It just returns 2. Okay, so let's say that in Java we have the same function and we call the add2 function with 2 arguments, right? In Java, these arguments will be evaluated as you call the add2 function. However, in Haskell, in this example, this argument, because this argument is a function call to the sum that sums up a list from 1 to 10 as both parameters, right? And so this will never actually be evaluated in Haskell because it never uses it. So it waits until the last minute to evaluate something. Okay. Next up, throughout this series, we will be using the Haskell tool stack. Now, the Haskell tool stack is generally just referred to as stack, and it's a cross-platform program, command line program for Unix-like distributions and Windows. And it's a great program for developing and managing Haskell projects, as it serves both as a dependency manager, meaning that we'll be able to install packages using stack, and also it creates an isolated environment for each of the projects that we have, meaning that it won't interfere with anything, any previous installations of something you might have on your computer that project is also supposed to use. I hope that makes sense. And so the overall goal for Stack really is to produce reproducible builds. Okay, this means that if you build your project today and it gives you some output, then if you forget about it and you send it to another developer a year from now, when he builds that project a year from now, it should return exactly the same thing. Okay, this is because there's a stack.yaml file inside your project that refers, the stack.yaml file is kind of a blueprint for your project, and it refers to a snapshot. Now, snapshots are basically just a way that Stack keeps track of what version of the Glasgow Haskell compiler that you have, which is the compiler for Haskell, the different versions of the packages that you might be using in your library. And as regard to packages, I said that Stack serves as a dependency manager. That's because, or mainly because, it is built on top of a popular, well, technically the package manager is a GHC package, I think, but Cable is sort of a wrapper around that, and that's what people primarily use to install packages. And Stack is sort of built on top of that, so everything that's included in Cable is also included in Stack. And I think that was about it for this video. Now in the next video I will go over some of the installation process for installing Stack on your computer. Specifically, I will go over it on a clean installation of Ubuntu 18.04. So I will see you in that video.